Working with Arduino. Lighting up the Arduino built-in LED. The code configures the built-in LED on an Arduino board to operate as an output device in the setup function. In the loop function, it repeatedly turns the LED on by setting it to high for 1 second, followed by turning it off by setting it to low for another second, creating a continuous blinking effect with a 1-second interval. This code programs the Arduino to make its built-in LED blink on and off at regular intervals. For this exercise, we just need one Arduino Uno. To lighting up the Arduino built-in LED, select Arduino microcontroller from Component Storage Box and add it to the workspace. The code makes the built-in LED on the Arduino board blink on and off, with each state lasting 1 second. Start with the setup function. The setup function runs once when the Arduino board is powered on or reset. Pin mode, LED_built-in output, sets the built-in LED pin, usually pin 13 on most Arduino boards, as an output pin, so it can send signals to the LED. Define the loop function. The loop function runs continuously after setup and contains the core logic. This is where the LED is controlled. Turn the LED on. Digital write, LED_built-in high, sends a high signal, 5V, to the LED pin, turning the LED on. Wait for 1 second. Delay, 1000. Pauses the program for 1000 milliseconds, 1 second, before executing the next line. Turn the LED off. Digital write, LED_built-in low, sends a low signal, 0V, to the LED pin, turning the LED off. Wait again for 1 second. Another delay, 1000. Ensures the LED stays off for 1 second before the loop starts again. Using Arduino with external components. Circuit view. For this circuit, you need Arduino Uno with following components. Hobby gear motor, NPN transistor, BJT, 1 kilo ohm resistor, green LED, 250 kilo ohm potentiometer. To develop the electronic circuit, please follow the steps outlined below. Open Component Storage Box. Select and bring one Arduino microcontroller, one potentiometer, one LED, and one hobby motor to the workspace. Also bring one battery pack, one resistor, and one NPN transistor to the workspace. These are required because a motor can draw more power than a USB port is used to providing. Rotate the potentiometer, LED, NPN transistor, and hobby motor and bring it onto the Arduino. Connect the potentiometer to the Arduino by wiring the center pin to pin A0, the right pin to 5V, and the left pin to GND. Connect the LED to Arduino by wiring the anode, longer leg, to pin 3 and the cathode, shorter leg, to GND. Connect the NPN transistor to Arduino by wiring the transistor's base to pin 5 using a 1K resistor. Connect the positive end of hobby motor to the transistor's emitter and the negative end to the GND on the Arduino. Connect the battery pack's positive terminal to the transistor's collector and its negative terminal to the GND on the Arduino. The provided Arduino code controls multiple components, such as the built-in LED, PWM pins, and an analog sensor input. The setup function initializes the hardware, and the loop function continuously performs the main tasks. In the setup function, pin mode is used to configure the built-in LED on LED_built-in as an output, the A0 pin as an input for analog sensor readings, and pins 3 and 5 as PWM output pins. Additionally, serial.begin 9600 sets up the serial communication at 9600 baud for sending data to the serial monitor. In the loop, the built-in LED is turned on and off with a delay that depends on the sensor value read from pin A0 using analog read A0. The delay dynamically changes based on the analog input value, creating a responsive blinking effect. Each analog value is printed to the serial monitor using serial.println analog read A0 for debugging or monitoring purposes. Finally, the same analog input value is used to control the brightness of the LEDs connected to PWM pins 3 and 5 via analog write. This code dynamically adjusts the behavior of the LEDs based on the sensor input, offering a simple demonstration of how analog inputs and outputs can be combined with serial communication for real-time control and monitoring. Using Arduino with a breadboard. There's a limit to the number of components you can easily add via direct wiring to Arduino. You can also expand the capabilities of your Arduino circuits by adding a breadboard, which creates more room for prototyping. To develop an electronic circuit, please follow the steps outlined below. Pick out components from the component storage box to add to your workspace similar to the circuit shown. Create wires connecting Arduino's 5-volt pin with the red plus power rail on your breadboard, and likewise GND with the black ground rail. To change your wire colors, select the color in the inspector or use the number keys on your keyboard to quickly switch between colors. Wire connections to 5-volt are typically red, and those connected to ground are black. Position your LEDs so the legs go to 2 different rows of the breadboard. Attach wires to any of the holes in the same row to make an electrical connection. Just like before, we want to connect the LED and resistor in series to pin 13 and ground. Following components are required. Arduino Uno R3, red LED, 220 ohm resistor. You can view the Arduino Uno schematic here. There's a limit to the number of components you can easily add via direct wiring to Arduino. You can also expand the capabilities of your Arduino circuits by adding a breadboard, which creates more room for prototyping. To develop an electronic circuit, please follow the steps outlined below. Pick out components from the component storage box to add to your workspace similar to the circuit shown. Create wires connecting Arduino's 5-volt pin with the red plus power rail on your breadboard, and likewise GND with the black ground rail. To change your wire colors, select the color in the inspector or use the number keys on your keyboard to quickly switch between colors. Wire connections to 5-volt are typically red, and those connected to ground are black. Position your LEDs so the legs go to 2 different rows of the breadboard. Attach wires to any of the holes in the same row to make an electrical connection. Just like before, we want to connect the LED and resistor in series to pin 13 and ground. In the setup function, the LED is set as an output pin. In the loop function, the LED is turned on high, waits for 400 milliseconds, then turns off low, and waits for another 400 milliseconds. This cycle repeats indefinitely, causing the LED to blink on and off every 400 milliseconds.